Lesson 6-7, Modeling with Exponential and Logarithmic Functions. Modeling means that you're choosing functions for the data. So you get a bunch of data, and you have to make up the equation or the function that fits the data. Well, if we have equally spaced x values, so you have a table, and your x is like 1, 2, 3, 4, 5. If the y values have a common ratio, so a multiple, so let's say you're always multiplying by 2, or always multiplying by a half or 3/4, then it's exponential. If the y values had the finite differences that we've done before, remember that was where you subtracted, and you subtracted, and you subtracted, and then it's those, and until you got all the same thing, that was a polynomial. For example, let's look at these and let's determine the type of function. So here's page 342, number 3. So we can look at this and we could try, see if it's exponential. We could do 3 divided by 4 is, well, 3/4, and then we can do 7 divided by 3, and you can see right away those are not the same. So it's not exponential. So let's try finite differences. 3 minus 4 is -1. 7 minus 3 is 4. 16 minus 7 is 9. 30 minus 16 is 14. And 49 minus 13 is 19. Are those the same? No, but let's try again. 4 minus -1 is 5. 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. Hey, look, those are all the same. So that was first order, this was second order, finite differences. Since that is true, it is polynomial with degree 2. It's x squared, which means it is quadratic. And if we wanted the function, we could use our calculator to do a quadratic regression. Why don't you try this one, number 1? Remember to check to see if it's exponential by dividing the y values. If they're all the same, it's exponential. If not, try subtracting to do the differences and see if it's polynomial. Pause while you do that. The answer is you're always multiplying by 4. Our ratio is 4, which means it is exponential. The y values multiply by 4 to get the next one. Once you know the type of function, you can use a calculator to get the function. On a TI-84, here's instructions. We've had them before. Stat edit. Put your points. If you want to see the points, you hit the y equals, highlight plot 1, press enter, keep it highlighted, press zoom, choose zoom stat. To get your regression, you go stat, calc, exponential regression, or logarithmic regression, depending on the type that you need. The NumWorks calculator, choose regression in the home screen. Data tab, enter your points. Go to the graph tab. You'll see the graph, you'll see the points, you'll see the regression. If it has the wrong regression, press OK and choose a different regression, and then the answer is just at the bottom of the graph. All right, so let's use our calculator to determine whether it's exponential and then write a function to model this. Now this is what we're going to call, quotes, real world data, which means that it doesn't perfectly fit the line. We want the best fitting one. So if we look for the common ratio, you're going to find out that it's not all the same. So what we're going to do is we're going to put it in the calculator and see what shape it is. So I have my regression thing. I'm going to put in the x values. This is the NumWorks calculator. I have to put in the y values. All right, and then I'm going to go up and look at the graph. Now, notice the points make that exponential shaping curve. It starts slow and then increases. So it appears like it could be exponential. So let's make an exponential regression. So I'm going to hit OK. I'm going to choose exponential. And look at that, it fits really pretty closely. So it looks like it is y equals a times e, that's the exp, to raise to the b times x. Some of your calculators, in fact the answer in the book, it doesn't have the base e. What you can do is you can just evaluate that to make it 12.06. If I go and evaluate, e raised to the point 571, see that it's about 1.77 raised to the x. So evaluated that, became that. This is the answer you'll see in the book. Why don't you try number 19? Pause while you the video. The answer should be 8.88 times 1.21 raised to the x.